Okay, today I'm going to go over identifying the Pythagorean theorem, and we'll be identifying right triangles and determining whether the three sides given form a right triangle using the Pythagorean theorem. So there's a couple of definitions we need to make sure we know. So in a right triangle, the two sides that form the right angle, which would be these two sides right here, are called the legs. And usually we call one leg A and the other leg B. And it doesn't matter which one you label A or B, they're interchangeable. But so the legs are the two sides that form the right angle. And then the longest side, which is always going to be the side that's opposite the right angle, is going to be called the hypotenuse. So, and we also call that side C. So side C is the longest side, and it is called the hypotenuse. And it will always be opposite the right angle. So it's the longest side in a right triangle. The longest side, and it's also opposite the right angle. And then we know that a right angle is just a 90-degree angle. So in the Pythagorean theorem, the key concept, and we modeled it yesterday, that in a right triangle, the squares of the length of the hypotenuse is going to be equal to the sum of the squares of the lengths of the legs. In other words, or in symbols, we say a squared plus b squared equals c squared. So this would be the area of the two smaller squares. The sum of those equals the area of the larger square. So let's look at these examples. Well, we have another definition. So if the sides of a triangle have lengths a, b, and c units such that a squared plus b squared equals c squared, then we say the triangle is a right triangle. So if we're looking at these three numbers, 9, 7, and 12, and again, the two shorter legs are the two smaller numbers. That's going to be side A and B, and then the longest side is always side C. So we're going to determine, is the a squared plus 7 squared, is that going to be equal to the side C squared, 12 squared? So all we really have to do is check that in our calculator. So I'm going to take my calculator, and let's clear this, and I'm going to do 9 squared plus 7 squared, and that's 130, and then I'm going to do 12 squared. And notice those two numbers are not equal. So the area of the two smaller squares does not equal the area of side C squared. So these three sides would not form a right triangle. So this would be a no. Because this is 130 and this is 144, and that is not equal. So let's try the next example. So 36, 48, and 60. Again, 60 is going to have to be side C because that's the longest side. So I'm checking, does 36 squared plus 48 squared, does that equal 60 squared? So, I don't need my camera. Calculator. 36 squared plus 48 squared is 3,600. 60 squared is also 3,600. So the a squared plus b squared does equal c squared. So this would be a yes. Those three sides would form a right triangle. Because 3,600 does equal 3,600. The next example, 26, 24, and 10. They have this in a little different order. So the largest number, 26, is going to be side C. So we have to add the two smaller legs, 24 squared plus 10 squared, and see if that's going to equal 26 squared, c squared. So I'm going to check that out. So 24 squared plus 10 squared is 676. 26 squared is also 676. So it does meet the Pythagorean theorem requirement that the two areas of the smaller squares add up to the area of the larger square. So this would be a yes also. Okay, try this next one on your own so you can pause it, and then when you're ready to check it, play the video some more. I'm going to go ahead and solve it though. So 5 and 12 are my two smaller sides, so that's going to be side A and B. So I'm going to do 5 squared plus 12 squared, and I'm checking, does that equal side C, which would be 13 squared. So again, side C has to be the largest side. So I'm going to take my calculator. 5 squared plus 12 squared is 169. 13 squared is also 169. So 169 does equal 169, so this would be yes. It does form a right triangle, those three sides. So these three sides would be 5, 12, and 13. So keep these notes for tomorrow because we'll be doing these next 4 examples in class for tomorrow's assignment. All right, that's it for today.